This is exercise 4.4 logarithms, just our introduction. If y equals a to some power of x, then x, I suppose you can look at it going backwards, x equals log to the base a of y, but it is, I always find it really difficult to remember this rule. The way I remember it, if y equals a to the x. Now, what I do, I take, you know how when you're trying to solve equations, you do the same thing to both sides? What you can do, because it's a to the x, you take log a of both sides. So just right here, take log to the base a of both sides. See, girls, because when you do logs, whenever you do a log, it's either log to the base 10, log to the base e, log to the base 2, or log to the base 3, or in this case, log to the base a. The reason I'm taking log to the base a of both sides is I've got a to the power of x. Now, if I've got y equals a to the x and I take log to the base a of both sides, so I go log to the base a of y equals log to the base a of a to the x. The reason is, I haven't taught you all the rules, but log to the base a of a is 1. Alright, so then you'll remember it as, well, log to the base a of a is 1. I haven't taught you the other rule where this x comes down yet. So I'm not going to teach you that yet. I'll teach you that later in the lesson. So log to the base a of a is 1, just so you get x is log to the base a of y. So if you see something like this, y equals a to the x, to get rid of this, to make it x the subject, you take log to the base a of both sides. So log to the base a of y, log to the base a of a to the x, log to the base a of a is 1. Alright? Now, what I might do is on your calculator, alright, I'm going to put these up on the board. That's just the rule, but I'm going to bring this across the screen. You got that? Do you have that written down? So this is the rule that you remember or learn. Some people remember it backwards. If y equals a to the x, then x is log to the base a of y. Going backwards. I like to take logs of both sides, and I always find it hard to remember anyway. Now, girls, if I ask you to evaluate the following, you need your calculators.
Is this question 1?
No, it's just an example. Example. Evaluate or find log to the base 10 of 5.3. Now, girls, you're not going to use that method there, but on your calculator, have you got your calculator? On your calculator, log to the base 10 on your calc is the log key. The log key. So on your calc, log to the base 10 is just the normal logarithm key. So if you want to enter that on your calc, you press log 5.3. So can you see the LOG button on your calculator? So log to the base 10 of 5.3, on your calculator, it's log. You got it?
It's on the pie.
Okay, everyone's got different calculators. So log of 5.3, what do you get?
0.7.
7, etc., dot, dot, dot.
So you don't actually put the 10?
No, the log to the base 10 on your calculator, that key is just the log key. That's what I'm trying to tell you. There are 2 log keys on your calculator. One of them is LOG. That LOG button on your calculator means log to the base 10.
What if it's a log to the base 7?
Wait, no, you can't do it. Okay? The other button on your calculator is an LN button. Now, LN is log to the base E. On your calculator, if you want to do, a log to the base E, it's the LN button. So if I ask you, for example 1, if I ask you to evaluate log to the base 10 of 5.3, you use the log button. Use log button. Got it? If you're asked to evaluate log to the base E of 80 on your calculator, log to the base E of 80, on your calculator you press ln 80. Does that make sense? So log to the base E on your calculator is ln. Now, the only 2 buttons that you can use on your calculator for logs are log 10 or log E. Your calculator does not do log 7, log 2, log 3, log anything else. When you want to do one of those other logs, we have to do change of base. Okay? So your calculator can only enter a log to the base 10 or a log to the base e. Got it? So if you're asked for log to the base e of 80, that's ln 80. Now you'll notice that ln 80 and log 80, if you do ln 80, it's different to pressing log 80. So if you do log to the base e of 80, what do you get? 4.38, let's say to do 2 decimal places. But if you do log to the base 10 of 80, what do you get?
4.38.
Log to the base 10. You press the log button.
1.9.
Do you get the difference?
1.903.
Etc. They're different. So you need to be looking what it is. Is it log to the base e or is it log to the base 10? And as I said, ln, so log to the base 10 and log to the base e are the only logs you can enter on a calculator. Now, let's see why we use logs. All right? So girls, that's the first thing. I only want to see log to the base e on your calc or log to the base 10. If you've been asked log to the base 2, forget it. You can't use your calculator until you've done something else with that log. Now, we're going to go back to that definition. All right. Now, another example. Find the value of log to the base 2 of a quarter. Now, girls, you can't do that. You can't do that. So what we're going to do is, if you're trying to find what that is, what a log really means is 2, this is what it means. 2 to the power of something, I know it looks a bit weird, but log to the base 2 of a quarter. It means 2 to the power of what is a quarter? Anyone know? Well, 2 to the power of 2 is 4. 2 to the power of what is a quarter? Negative 2. Yeah, that is the answer. But, girls, if you look how you've got log to the base 2 of a quarter, you know how I said if y equals a to the x, then what's my rule? Log to the base a of y equals x. So if you look at what you've been given, I can say, well, in my case, x is log to the base 2 of a quarter. Can you see? I know you're getting a bit confused. I thought so. You know what? I might just teach you change of base. It might be easier. I think I'll teach you change of base. All right. What I'll do, this is one way of doing it. You know, if you're trying to work out log to the base 2 of a quarter, it sort of looks like this format. Log to the base up. The log is the inverse of an exponential function. All right? The log is an inverse of an exponential function. One sec. Are we ready? Logarithm, what is a log? It's another name for the index or power of a number. Logarithms are related to exponential functions and allow us to solve equations such as 2 to the power of x is 5, okay? And they also allow us to change subjects of exponential equations, such as y equals e to the x. We're able to change the subject of the equation to x, all right? Now, I don't think that actually tells you. You know how I said that you cannot enter anything but log 10 or log e on your calculator? There is a rule. Log to the base a of b equals either ln b over ln a, or it equals log to the base 10 of b over log to the base 10 of a. So if you're asked log to the base a of b and you can't enter it on your calculator, the only reason you wouldn't be able to enter it on the calculator is if a is not an e or a 10. You know, if a is an e, you can put it on the calculator. If a is a 10, you can put it on the calculator just as we did up there. Look, log to the base e of 80 means use the ln key. Log to the base 10 of 80 means use the log key. If you are not given base e or base 10, we use what's called the change of base rule. The change of base rule. So log to the base a of b is just ln b over ln a. Doesn't ln b mean log to the base e of b over log to the base e of a? Or you could do it as log to the base 10 of b over log to the base 10 of a. In other words, it's that quantity, log of that quarter over log of 2. Now let's try it. log to the base 2 of a quarter, I said you could do ln quarter over ln 2. Get an answer for that. Or log to the base 2 of a quarter, I can do a log, which is log to the base 10 of a quarter over log to the base 10 of 2. Okay, now do both of them on the calc and see what you get. So ln a quarter divided by ln 2 gives me, and so you could have chosen either. You can choose to do log to the base e of a quarter over log to the base e of 2, or you could have chosen to do log to the base e, log to the base 10 of a quarter over log to the base 10 of 2. Do you get it? And you'll get negative 2 for both. Now, if you look at that, what a log really means, it's got to do with indexes or powers. What this really means is 2, the other way you can look at it is 2 to the power of x is 2 to the power of something is a quarter. That's the other way you can look at it as. 2 to the power of something is a quarter. 2 to the x, isn't a quarter 1 over 2 squared or 2 to the negative 2? Notice our answer is comparing. We were doing these last year, 2 to the power of x is a quarter. You wrote that as 2 to the power of x is 1 on 2 squared. Or 2 to the power of x is 2 to the negative 2, therefore the x is a negative 2. This is what logs are used for. They're used for working out powers, all right, in equations, all right? It allows you to make x the subject in a way, or work out x.
Log 1/4, do we assume that the down the bottom is 10?
Yeah. If it says log, yes. If it says log, it's down the bottom, it's 10. Yes. Okay? If it says ln, the base is e. Got it? So I should have written this either as log to the base e of a quarter over log to the base e of, or I can write it as log to the base e of b over log to the base e of a. All right? Now that allows you to work out anything with a base other than 10 or e. All right? That's the change of base rule. What they're trying to get you to do in the first exercise is know that 2 to the power of something is a quarter. That's actually the real meaning of what logs are used for. All right? Okay. I'm just going to, following on from that last example, I mean, you can use change of base here, but let's see if you can, you know how I was saying the definition of logs? This really means 5 to the power of what is 1? What do you get? X is? Now, let's use change of base. How do I do it? The real definition of logs, let's use change of base. What do you get? Change of base. What would I write? Log to the base 5 of 1 equals, you can't do base 5, so you'll choose ln or you'll choose log. Log 1 over log 5. Doesn't matter which one. Either. Doesn't matter. Log 1 over log 5, what do you get? 0. You know why? Because log 1, 0. Now, the other way you can look at it, what they want us to do in this first exercise is not to do it like that. They want us to realize that logs mean 5 to the power of what is 1. Can you see what I'm doing? So, all right, girls, 3 to the power of, trying that second method, 3 to the power of what is 9? So that's 2 over 2 is 1. That's
I get the right side. Where did that come from?
because this is, notice how the answer is 0? This is what logs really mean. 5 to the power of what is 1? That's the answer. Look at this. Log to the base 3 of 9. Let's just say I'll give you log to the base 3 of 9, right? You can do, no, you can do ln 9 over ln 3 with change of base, right? But it really means 3 to the power of what is 9? No, it's not. 3 squared is 9. So x is 2. Now, if you do ln 9 over ln 3 on your calculator, you will get what? Do it. 2. In the end, yes, you'll do change of base. But I'm just trying to, people are asking what do logs mean. I'm trying to show you what they mean. So this means 4 to the what is a half, but you know change of base. With change of base, this is what? ln a half over ln 4. If you want to use change of base. Got it? But really, this is what it's asking you. Now, girls, tell me what you think that power is. It's, girls,
How can you do that in calculator?
you can't. Change a base, you can do this. And what do you get? Negative a half. Girls, what's 4 to the negative half? Just checking our answer. Doesn't it mean 1 over 4 to the half, which means 1 over the square root of 4, which is a half? That's why the answer is negative a half. Because square root of 4 is 2. To get 1 over 2, it's to the power of negative. So girls, this answer of negative a half, what does it mean? It means that 4 to the negative a half is a half. That's what it means. 4 to the power of what is a half? That's the meaning of the log. But you can use change of base. You don't have to know the meaning. All right? All right, I want to do log laws now. Please. Definition of logs. You know how I said if y equals a to the x, do you remember how it goes? X equals what? You can think of the backward log to the base a of y, or you could take log to the base a of both sides, so log to the base a of y, and take log to the base a of this side, log to the base a of a is 1, you get x equals log to the base a of y. Now, see that y equals ln x? If you want to write this in index form, girls, you know how ln means log to the base e? Alright, I'll show you something here. Look over here, look over here. Log to the base a of a is 1. Log to the base e of e is 1. That means ln e is 1. Watch. Log to the base 10 of 10 is 1. I want you to do ln e on your calculator, see what you get. And I want you to do log to the base 10 of 10 on your calculator. How do you do that? What do you do to log 10? Do ln e on your calculator, which means log to the base e of e. Tell me it's 1. Do log 10. Log to the base 10 of 10 means log 10. What does that equal? 1. So, if you ever see log to the base e of e, it's 1, which means ln e is 1. If you ever see just a normal log 10, because that's to the base 10, that's 1. But you can see it the other way as well. E to the log e is 1 too. So, can you do e on your calculator to the power of ln? Oh, do e to the ln1 on your calculator. Tell me what you do. Yeah, so I want you to press e to the ln1. Do you know how to do that on your calculator? Can you do e to the ln2 on your calc? E to the ln3. Tell me what you think happens to e and ln. So you can think of them as cancelling. Girls, this is how I'm going to get you to remember this rule. If you do e to the power of ln1, you get 1. In other words, e to the log e basically cancel out. E to the ln2 is 2. E to the ln3 is 3. Now, wait, I'll continue with that up here. Can you do 10 to the power of log to the base 10 of 1? What do you think you would get? 10 to the log base 10 of 2. I want you to enter it on your calculator. I want 10 to the power of log 1. I want you to do it. I want you to do 10 to the power of log to the base 10 is log 2 on your calculator. Do it yourself. All right, so 10 to the log 10 5 is
5.
So girls, whenever you see, that means 10 to the power of. Oh, it's a 1. 10 to the power of, how do you do to the power of on your, of log 1. 10 to the power of log 2. 10 to the power of log 5. Tell me what you get. You're exploring. So, girls, 10 and log 10 cancel. That's what I want you to remember. 10 and log 10 cancel. E and ln cancel. E and ln cancel. E and ln cancel. Whether you do ln log to the base 10 of 10 or 10 to the log 10, 10 to the power of log 10, they cancel. So, are you okay with that?
Yes.
So, in other words, when I have the definition, girls, when I have the definition y equals a to the x and I decide I want to change how it looks and write it as a log, well, I think what will get rid of that a? Log to the base a. So if I do, so I just need some room. Wait. So just watch what I'm going to do. So if I've got y equals a to the x and I take log to the base a of both sides, you tell me what cancels on the right. The log to the, so that gives me x equals log to the base a of y. That's how you get that rule. If y equals a to the x, then x equals log to the base a of y. Now, the other way you can remember it is to remember it backwards. If y equals a to the x, then x equals log to the base a of y. But I like to do it this way because I always find it really hard. Or isn't it a to the power of, I find it hard to do. A to the power of what is that? A to the x is y. I just find it hard to remember the rule. So, here, write this in index form. Doesn't that mean y equals log to the base e of 4? How am I going to get rid of that e, log to the base e? I take e of both sides. E to the y equals e to the log e of 4. E log e cancels. You get e to the y equals 4. That's the opposite. So, y equals ln 4 means y equals log to the base e of 4. How do you get rid of the log e? You take e to the power, you do e to the power of both sides. E to the log, e to the y, e to the log e to the log e cancels. You get e to the power of y is 4. What would you take? It is 7. 7. 7 to the y equals 7 log 7x. What cancels? 7 log 7 cancels. 7 to the y equals x. Do you sort of get that? I know, it is. Or x to the half is root 3. That's the other way. 7 to the y equals x. 7 to the y equals x. But people forget, they find it hard to remember how to do it. See, you want to get rid of that log x. What's going to cancel the log x? X to the power of. No? X to the power of that equals that. That's the definition of a log. If y equals log to the base a of x, no, you're finding it hard. You can do x to the half equals root 3. A lot of people find the rule, I think, guess what? The rule's on your formula sheet. The rule is on your formula sheet. So on your formula sheet it says that if y equals a to the x, then log to the base a of y equals x. So if you compare that with that, isn't x the half? No, it's not. Y, yes, x is the half, y is the root 3, a is the x. So you can compare it on your formula sheet.
So you can just straight up say
X to the half is root 3. That's what that means. 7 log 7, 7 to the power of log 7 will be the same as log to the base 7 of 7. You'll get the same result. Well, no, 7 log 7 cancels, you get x. Whatever x, if you did 7 to the, like you know how we were doing 10 to the log 10 of 5 and we got 5 when you did it? Obviously the 10 log 10 cancels. No, I know, we haven't done it. Tell me what that, because, see girls, you know how here we said, Oh, jeez. You know how back up here, from there to there? No, I'm using that rule. So I've got, so here, if you compare that with that, isn't the half the x?
Yeah. But how did you just put x to the half? How did you just put it?
You know when I was saying here, look, 5 to the 0 is 1. Remember when I was doing that? It's the same sort of thing. 5 to the answer will give the 1. 3 squared is 9. So 3, the answer is 2. 3 squared is 9. Look. So x to the half is root 3. Or, if you look at this, girls, the other thing you can do is you say, if you take x of both sides, x log x cancel, and you get root 3 equals x to the half.
Oh, okay, that makes more
That's what I'm trying to, it's so hard to use the definition. I find it really hard to follow that definition. What I do, I say what's going to cancel that log x? X to the power of. Take x of both sides. Do x to the power of both those sides. So then x log x cancel and you get root 3 equals x to the half. What does x to the half mean? Square root of x is square root of 3. Compare. What's x? The next one. You can do, wouldn't x to the power of fix both sides?
Yeah, I find that easier.
X to the power of that. So what would you be left with on this side? 4 equals x cubed to the third. Got it? If you take x of both sides, x to the power of both sides, x log x we know cancels. X to the third is 4. Yeah. X to the power. Let's say I've got, I'm doing like this. I'm raising each side to the power, not to the power of x, but x to the power of what's already there on both sides. Do you get what I'm doing? Because x log x cancels. All right? That's how I look at it. All right?
So now don't you just do what?
Well, isn't the cubed root of x equal? So that means, girls, wouldn't we cube both sides? Yeah. It's, wouldn't you cube both sides?
So if you that's
What's the opposite of power of a third? That means the cubed root of x is 4. The cubed root of what is 4? 64. Got it? Or you could, if you were stuck, wouldn't you take, raise both sides to the power of 3? Look. No? I can see so many blank, confused faces here. I don't know.